Using polyvinyl chloride conduit above ground is an electrical code violation because polyvinyl chloride conduit can only be used underground or in wet locations. It cannot be used above ground. Furthermore, using non-metallic sheath cable, also known as Romex, for outdoor applications is also an electrical code violation. Non-metallic sheath cable is not suitable for outdoor use. Outdoor wiring must use underground feeder cable or direct burial cable. Using non-ultraviolet rated polyvinyl chloride conduit above ground will degrade over time, exposing the wire to hazards. Also, using the wrong wire type can lead to electrical fires. Using number 14 American wire gauge non-metallic sheath cable for a run of 1,000 feet with 12 lights drawing 60 watts each could result in an unacceptable voltage drop. The recommended solution is to install underground feeder cable or direct burial cable in a weatherproof conduit such as galvanized steel or rigid metal conduit. Use number 12 American wire gauge wire to minimize voltage drop. Ensure the conduit is properly secured and ultraviolet protected. Have a qualified electrician inspect and approve the installation to ensure safety and code compliance. Let's delve deeper into the specifics of why these recommendations are crucial for a safe and code-compliant outdoor lighting installation. Firstly, consider the purpose of conduit in electrical systems. Conduit serves as a protective pathway for electrical wires, shielding them from physical damage, moisture, and other environmental factors. When selecting conduit for outdoor use, it's imperative to choose a material that can withstand the elements and maintain its integrity over time. Polyvinyl chloride conduit, while suitable for underground or wet locations, is not designed for above-ground exposure to sunlight. Prolonged exposure to ultraviolet radiation can cause polyvinyl chloride to become brittle and crack, compromising its protective function. This can leave the wires vulnerable to damage, increasing the risk of electrical shock or fire. Instead, galvanized steel or rigid metal conduit are better choices for above-ground outdoor applications. These materials offer superior durability and resistance to ultraviolet degradation, ensuring long-lasting protection for the wiring. Furthermore, when running electrical wires outdoors, it's essential to use a cable type that is specifically designed for this purpose. Non-metallic sheath cable such as Romex is intended for indoor use in dry locations. It lacks the moisture resistance and ultraviolet protection required for outdoor installations. Using non-metallic sheath cable outdoors can lead to insulation breakdown, corrosion, and ultimately, electrical failure. Underground feeder cable or direct burial cable are specifically designed for outdoor use. These cables are constructed with moisture-resistant insulation and a rugged outer jacket that can withstand direct burial in the ground. They are also ultraviolet resistant, ensuring long-term performance in outdoor environments. Addressing the potential for voltage drop is another critical aspect of outdoor lighting installations. Voltage drop refers to the decrease in voltage that occurs as electricity travels along a wire. Excessive voltage drop can cause lights to dim, appliances to malfunction, and motors to overheat. The amount of voltage drop depends on several factors, including the wire gauge, the length of the run, and the current draw of the connected devices. Using number 14 American wire gauge wire for a long run with multiple lights can result in significant voltage drop, especially if the lights are drawing a substantial amount of power. To minimize voltage drop, it's recommended to use a larger wire gauge, such as number 12 American wire gauge. A larger wire gauge has lower resistance, allowing electricity to flow more easily and reducing voltage drop. In addition to selecting the appropriate conduit and wire types, it's also important to ensure that the installation is properly secured and protected from ultraviolet radiation. Conduit should be securely fastened to supporting structures using appropriate clamps and hangers. This prevents the conduit from sagging or shifting, which could damage the wires inside. If polyvinyl chloride conduit is used in areas exposed to sunlight, it should be painted with an ultraviolet-resistant coating to prolong its lifespan. Finally, it's crucial to have a qualified electrician inspect and approve the installation to ensure safety and code compliance. A licensed electrician has the knowledge and experience to identify potential hazards and ensure that the installation meets all applicable electrical codes and standards. This provides peace of mind and helps to protect against electrical accidents and fires. In summary, installing outdoor lighting requires careful attention to detail and adherence to electrical codes and standards. By using the appropriate conduits and wire types, minimizing voltage drop, and ensuring proper installation practices, you can create a safe and reliable outdoor lighting system that will provide years of trouble-free service. We remember that safety should always be the top priority when working with electricity. If you are not comfortable performing electrical work yourself, it's always best to hire a qualified electrician to do the job. Now let's talk about the specifics of each electrical code violation in more detail. Firstly, the improper use of polyvinyl chloride conduit. The National Electrical Code, or NEC, specifies the approved uses of various types of conduit. Section 352.10 of the National Electrical Code outlines the permissible uses of polyvinyl chloride conduit, and it clearly states that polyvinyl chloride conduit is permitted for use in underground installations and in locations subject to severe corrosive influences. However, it explicitly prohibits the use of polyvinyl chloride conduit in exposed locations where it is subject to physical damage or where the ambient temperature exceeds the temperature rating of the conduit. In this scenario, the polyvinyl chloride conduit is being used above ground, where it is exposed to sunlight temperature variations and potential physical damage from impact. Therefore, this constitutes a clear violation of National Electrical Code Section 352.10. The correct type of conduit for above-ground outdoor use would be rigid metal conduit, or intermediate metal conduit, or even electrical metallic tubing when installed according to the code. These types of conduits are designed to withstand the elements and provide superior protection for the enclosed conductors. Secondly, let's address the improper use of non-metallic sheath cable, or ROMEX, in an outdoor environment. The National Electrical Code restricts the use of non-metallic sheath cable to dry locations. Section 334.10 of the National Electrical Code specifies the permissible uses of non-metallic sheath cable, and it clearly states the non-metallic sheath cable is permitted for use in 1 and 2 family dwellings, multifamily dwellings, and other structures. However, it explicitly prohibits the use of non-metallic sheath cable in wet or damp locations, or where exposed to corrosive fumes or vapors. In this scenario, the non-metallic sheath cable is being installed in an outdoor environment where it is exposed to moisture, temperature variations, and ultraviolet radiation from the sun. This constitutes a clear violation of National Electrical Code Section 334.10. The correct type of cable for outdoor use would be underground feeder cable, or direct burial cable, as mentioned earlier. These cables are designed to withstand the rigors of outdoor environments and provide reliable electrical service. Thirdly, we need to discuss the safety concerns associated with using the wrong materials in an electrical installation. When the incorrect type of conduit and cable are used, it can create a number of safety hazards. Polyvinyl chloride conduit that is exposed to sunlight can become brittle and crack, exposing the enclosed conductors to moisture and physical damage. Non-metallic sheath cable that is installed in a wet location can absorb moisture, leading to corrosion and insulation breakdown. These conditions can create a risk of electrical shock or fire. In addition, the use of the wrong materials can void the manufacturer's warranty and create liability issues in the event of an accident. It is essential to always use the correct materials for the specific application to ensure the safety and reliability of the electrical installation. Fourthly, let's analyze the potential for voltage drop in this circuit. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor. The amount of voltage drop depends on several factors, including the length of the circuit, the size of the conductor, and the amount of current flowing through the conductor. The National Electrical Code recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. In this scenario, the circuit consists of 12 post lights, each with a 60-watt fluorescent bulb, and the longest run is 1,000 feet. The total load on the circuit is 12 lights multiplied by 60 watts per light, which equals 720 watts. At a voltage of 120 volts, the current flowing through the circuit is 720 watts divided by 120 volts, which equals 6 amps. Using number 14 American wire gauge wire for a 1000-foot run with a 6-amp load will result in a significant voltage drop. According to voltage drop calculators, the voltage drop would be approximately 71.4 volts, which is far greater than the recommended 3% limit. This excessive voltage drop can cause the lights to dim, reduce their lifespan, and potentially damage the electrical components. To mitigate voltage drop, it is recommended to use a larger wire size, such as number 12 American wire gauge. Using number 12 American wire gauge wire will reduce the voltage drop to an acceptable level. Finally, let's discuss the recommended solution for correcting these electrical code violations. The recommended solution is to remove the existing polyvinyl chloride conduit and non-metallic sheaths cable and replace them with the correct materials. Install rigid metal conduit or intermediate metal conduit for the above ground portion of the circuit and use underground feeder cable or direct burial cable for the wiring. Use number 12 American wire gauge wire to minimize voltage drop. Ensure that all connections are made properly and that the circuit is grounded in accordance with the National Electrical Code. Have a qualified electrician inspect the installation to ensure that it meets all applicable codes and standards. By following these recommendations, you can create a safe and reliable outdoor lighting system that will provide years of trouble-free service. Let's explore further into the implications of using the incorrect materials and the importance of adherence to electrical codes. Using non-approved materials not only violates established safety standards but also increases the risk of equipment failure, electrical shock, and fire hazards. Electrical codes like the National Electrical Code are designed to provide a standardized set of rules and guidelines that ensure electrical installations are safe and reliable. These codes are regularly updated to reflect new technologies and best practices. Ignoring these codes can lead to serious consequences. One of the primary reasons for using the correct type of conduit is to protect the electrical conductors from physical damage and environmental factors. Rigid metal conduit, intermediate metal conduit, and electrical metallic tubing provide a robust layer of protection against impacts, moisture, and ultraviolet radiation. These conduits are designed to withstand the rigors of outdoor environments and prevent damage to the enclosed wires. Non-metallic sheaths cable, or Romex, on the other hand, is not designed for outdoor use. The outer jacket of non-metallic sheathed cable is not ultraviolet resistant and can degrade over time when exposed to sunlight. This can lead to cracking and brittleness, exposing the conductors to moisture and other contaminants. Once the conductors are exposed, they can corrode and short-circuit, creating a risk of electrical shock or a fire. In addition to protecting the conductors, the correct type of conduit also provides a path for grounding the electrical system. Grounding is an essential safety measure that helps to prevent electrical shock in the event of a fault. When a fault occurs, the grounding system provides a low-resistance path for the fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. Without a proper grounding system, a fault can cause the metal parts of electrical equipment to become energized, creating a risk of electrical shock to anyone who comes into contact with them. Non-metallic conduit does not provide a grounding path, so it is essential to install a separate grounding conductor when using non-metallic conduit. The grounding conductor must be properly sized and connected to the grounding electrode system to ensure effective grounding. Another important consideration is the ampacity of the conductors. Ampacity is the maximum amount of current that a conductor can carry safely without overheating. The National Electrical Code specifies the ampacity of various types of conductors based on their size, insulation type, and installation conditions. When selecting conductors for an electrical installation, it is essential to choose conductors that have sufficient ampacity to carry the expected load. Overloading a conductor can cause it to overheat, leading to insulation breakdown and potentially a fire. In this scenario, the use of number 14 American wire gauge non-metallic sheath cable may not be sufficient to carry the load of 1260-watt fluorescent lights over a distance of 1,000 feet. The voltage drop calculation earlier showed a very excessive voltage drop. This excessive voltage drop can cause the lights to dim, reduce their lifespan, and potentially damage the electrical components. The recommendation to use number 12 American wire gauge wire is based on the need to reduce voltage drop and ensure that the conductors have sufficient ampacity to carry the load safely. Remember to always consult the National Electrical Code and local electrical codes for specific requirements and guidelines. These codes are regularly updated to reflect new technologies and best practices, so it is essential to stay informed about the latest changes. If you are not comfortable performing electrical work yourself, it is always best to hire a qualified electrician to do the job. A licensed electrician has the knowledge and experience to ensure that the electrical installation is safe, reliable, and compliant with all applicable codes and standards.